So, as you might know, my name is Emil. I'm with Collabora. I have a name tag today. Thank you, organizers. So this is how you can reach me, and today I'm going to be giving you a couple of talks. First one is about bootloaders, 1 or 2 or 3 or 5, depending on how you count them, as used on the SteamDeck. So what's next? Let's have a quick overview of what I'll be talking about. First is I'll have a very quick glance at the Fitting Everything Together. It's a blog post by Lennart last year. And it provides a very nice overview of all the different systemd components, how everything should interact and work at least in the vision he had. Then I'm going to point out some of the partitioning. Oh, let's see what I can do. Okay. Then okay. IT problems. Maybe that's why it was disconnecting. Okay. IT problems. Oh, at least one works. Okay, then I'm going to have a quick overview of the partitioning layout and bootloaders on the SteamDeck, and then we're going to explore them one by one, and then we're going to do a bit of a comparison of what we have on the deck versus systemd boot, and whether it's actually feasible to use systemd boot at some point in the future. Okay, having a quick look. If you don't know, here's where the actual blog post is. And as I mentioned before, it covers pretty much everything from the base assumptions of what the requirements are, from the security model, to the update process, to the partitioning, to the boot chain, to the partition discovery, and so on and so forth. The part that we're actually interested in is the partitioning. I hope you can actually read some of that. If not, it starts with a single ESP partition at the top, and then we're having a user partition, which is hermetic read-only partition. Then we're having a couple of verity partition to ensure a level of integrity. Then, as it says on the very first boot, those partitions are essentially replicated, although being empty. And on sequential boot, on sequential updates, it alternates which partition set is used, which one is actually being updated, and so on. Okay. There is a particular thing to note is that, as you can see, perhaps at the very bottom, you're having a single root partition, followed by the home and the swap partition itself. If I remember correctly, the blog post does not really answer who and how the policy is made behind the sizes or the layout of those. So this is something to keep in mind as part of my talk. Actually, my other talk. So let's have a quick look at the partitioning on the SteamDeck. As you can see, slightly different. It's starting with a single EFI partition. Then we're having a couple of pseudo EFI partitions that contain our second bootloader. Then we have a couple of root partitions, and then some variable var partitions. I'm not really going to cover why we chose this particular var and root layout. That's going to be part of the next talk. For now, I'm going to focus on the first three, essentially the boot chain. So if we are to have a look within, on the left is the one we're having as the first actual bootloader. It's a custom piece of software. It's open source. If you know how to get packages on Arch, you should be able to fetch that, explore, and have fun. We have the EFI binary, and we're having a boot control tool used for handling all the various metadata from user space. An important thing to bear in mind here is that apart from those, we're having, as you can see, some configuration files. Those files contain information such as the actual, boot state, whereas the last boot was successful, how many of those were successful, unsuccessful, when the boot was attempted, when it was actually completed, and so on. As you know, perhaps better than me, all of those partitions have to be VFAT, and resilience is not that great. Although our current choice of this particular layout was emphasized on the factor that we need some of that auxiliary metadata, as I said, about the boot status, success. That is explicitly very, very helpful, not explicitly, when you are actually having a bunch of devices and you need to troubleshoot them remotely, and obviously nobody really knows about bootloaders or care, but what they can do is they can just send you a couple of files with all the metadata that you can actually use locally to troubleshoot. On the pseudo partitions, as I said, we have two of those. We are having the second stage bootloader, which maybe you can see what it is. And in addition, we're having some additional information about the partitions or the part sets. Those are pretty simple files with just a number of part UUIDs within. Okay, so let's have a quick look at the various components. As I said, the first stage is it's a custom piece of software, fairly straightforward, a few thousand lines worth of code. It essentially goes through the configuration files and decides in which partition it's going to go and passes on forwards. If the button, the ... button on the SteamDeck is pressed, it can draw a fancy, well, the new version might draw a fancy menu. The current one is a little bit rough, but still has fairly good information, such as which part sets are available, which one you booted last time, if there were any failures during boot. Not something that an end user or a person will usually do, but as needed, it's there. And then it passes on to the second stage. And as I said, Grub, yay. So, what is our Grub? It is effectively an upstream copy with some patches. They used to be 200. And they were mostly inspired by the SteamOS legacy from Debian. And we've slowly been chipping away. But as you can imagine, it's not that easy task. So that brings the question in a way, can we do something else altogether? So behind the scenes, what some of those patches do is they enhance the scripting language so that details such as resolution and whether the menu should be presented are more, let's say, configurable on demand. Apart from that, as I said, we're having an extra Grub module. A Grub module implements a couple of bits. First is the initialization, does that fairly early. It reads a few user configuration variables, which are completely undocumented, yay. And based on those, it can make some decision within the Grub configuration, scripting, whatever language it is. By default, obviously, you want a seamless boot. So that means the video mode is set to keep. Another thing to keep in mind is that the device itself has a portrait display. That means we need to be able to pick the correct resolution, whether it's rotated, and so on and so forth. And once that is done, we also need to be able to determine what kind of a boot or kernel command line it does, which perfectly ties with what was talked about a moment ago. So the second piece is the boot command. As you can imagine, it doesn't do much, just boots. Oh, increments a timer, sets a flag, and adds an extra argument for discovery where the partition is. Since, unlike the traditional set, we're having a separate non-default UUID for the partition. So let's have a quick look at how it compares with regards to SteamDeck boot. So there are a few things that we need to ensure to sort of reach a bridge between the two. First is boot resolution and panel orientation. Based on my knowledge, there's no way to achieve that with systemd boot. I know there's a toggle with lowercase r that you can do that at runtime, but that's not really the best option, I believe. In addition, there is a boot counter. As I said, we're having actually a few of those in our custom boot chain to actually know when things are attempted. And unlike systemd boot, who has a similar concept but embeds that as part of the file name, we don't discard this information. Based on my understanding, at least on the spec, is that once a successful boot is reached with systemd boot, all that information is discarded. So on sequential boot, if you somehow made something miraculously wrong and your boot doesn't proceed, that information is no longer utilized. But at the same time, do we actually need all that information in our custom loader? Do we need all that information in systemd boot? Thinking about it, didn't we just say that the first stage or bootloader already does some crazy handling, reading, writing of those files? We can actually shuffle all that counter in there. So if we look at the next piece, we are having the quote-unquote verbose flag, which serves two purposes for us. One of the purposes whether the boot menu is going to be displayed. We're talking about the Grub menu here, and obviously the one prior. There's a verbose1 flag that was recently introduced, and if we actually compare those, systemd already has variables for that. I believe there were non-volatile EFI variables that we can easily use and just discard all that from our custom stack. Another piece that was, as I said in the talk just prior, there was an interesting discussion, I believe, that opened up, is whether systemd boot can pick between multiple command lines, if I understood correctly. And this is essentially what we want to a degree. We want a case where you have the standard quiet boot command line, and you want to have another one which is a little bit more verbose. And in our case, we need to add a few extra arguments in there. I would love to see a slightly better solution than what we have at the moment, because our current code in the custom module does command line tokenization and parsing and addition and removal, and it does the job. I'm not sure if it's the best code that's out there. And the last piece, as I said before, is the actual custom part UUID that we feed on command line, which, again, looking back, there is an actual systemd variable that can be used. So our first stage bootloader can set that variable, hand things off to systemd. Systemd is going to say everything's great. It's going to proceed. Our initial RAM disk is going to look at this and say, oh, so now I know where all my metadata for the partitions are. I know what to mount where. So from the list we started before, it was about 5 or 6 entries. We ended up with just one. How do we specify the resolution and panel orientation? And I had the exact variable in my notes, but turns out systemd already handles that. Just it's not documented. Why is the question? Is it? Documentation. Okay, fair enough. No problem.
You want to say?
I mean, it's great that it does. I'm just a little bit confused why it's not documented. The rest of the ecosystem is really nicely documented.
Okay, now this works. So there's actually the configuration file option. That one should actually be documented. And if the EFI variable is not documented, it's just oversight.
Okay.
But the panel orientation, like, I mean, the resolution is certainly there,
yeah.
But the panel orientation, I don't think there is a generic API even for that in EFI.
I don't think either, but from what I've seen, the variable itself that systemd uses takes the index in the mode list as given by UEFI. In our lucky case, there is one resolution that is actually the perfect orientation.
But yeah. But anyway, the R button just changes the EFI variable itself, right? Like so, it sounds like.
Okay.
File a bug that we document, then we will document it.
Okay. I was a little bit worried that it's either being deprecated or discouraged or anything along those lines, but.
And on the R versus config in type 1, I think we can add some configuration line if we on loader.conf. That's the other thing you said, right? That you have to press the button. There's no loader.conf to change that. Didn't you say something? There is? All right, perfect. All right, sorry.
Nice.
Does Valve control the UEFI firmware of the device in any way, or is that, do you just get that from AMD?
I do not know. I just see BIOSes coming in my way, and it's automatically flashed.
Sure, but if they do control the BIOS in some way,
Yeah.
why couldn't they just change what the default mode that the BIOS picks, since it's available to the BIOS, as you're saying, and then the bootloader doesn't even have to worry about it at all?
Yeah, that's an option, but I need to bring it up to them.
Any other comments or questions? Anybody? No? Please continue.
Okay. So I'm just gonna basically finish with this. Should we put our eggs in the systemd boot basket?
Yes.
And most importantly, if we come tomorrow or in a few weeks or in a few months, in a few years' time, with a certain feature that we might need, can we rely on the community of helping us out? Obviously, we're comfortable and skilled to write the patches, more like. Okay, so I got a thumbs up from Lennart, so I'll take that as a yes.
If you buy enough beer, then yes.
Bear in mind, this talk is just an exploration. There's no. Let's see. Yeah. So yeah, thank you very much, everyone. Any more questions, comments, in generally about what I've presented would be great. If we don't diverge into other directions, that'll be appreciated.
Any questions, folks? Well, this is great. So I think there's nothing. Going once, going twice. Well, thank you very much.
Thank you.